I'm an applied research scientist at NVIDIA and have been working on federated learning for the last couple of years, mainly doing algorithmic research, but also working heavily with our software tools on the development side, like the NVFlare, and together with MONAI, we started building some useful APIs around federated learning use cases. So let me do a little introduction there. I prepared some slides, but I will not go through all of the background in the interest of time. Mainly what we're interested in is this federated learning API in MONAI. So I think at least people who have been attending yesterday should be aware of the MONAI bundle concept. So the idea is really that we can use models that have been developed in MONAI. We can package them in this bundle form and then apply it across different use cases like a MONAI deployed, MONAI labeling, or MONAI federated learning, right? So this bundle gives you a standard on the how the training algorithm should look like, what is your model, what is your data loading, augmentations and things like that, loss functions. All that is included in a bundle. And the idea is that now in the federated learning setting, we can basically send that bundle to a federated learning server. The server is then, here we're mainly talking about a server-centric federated learning implementation. So the server is distributing these bundles to the different clients. In the healthcare sector, that's mainly different hospitals. And then they use this client algo API, which is kind of our abstract base class, to interact with this bundle. I will show later that that API has kind of the main functionalities that you need for running a model in a federated learning scenario. So it has like a training call, it has a evaluate the model call, and get the current weights or weight differences. So that's in order to work with the bundle, we have on the client side a MONAI algo, which kind of is already set up to pass this bundle, set up all the training logic, and run it. So by having this abstract API, we can basically be very agnostic to the underlying federated learning framework that you want to use. And we have one example currently that uses NVIDIA's federated learning platform called NVIDIAFlare, which I will show in more detail. So just a bit of background on NVIDIAFlare. It's our federated learning SDK, you could call it. It's actually a pretty lightweight Python library that you can install for various applications. And it's really agnostic to the underlying training framework that you want to run, and pretty agnostic across different industries. So we've done a lot of work in healthcare and in medical imaging with the MONAI working group as well. NVFlare tries to be attractive to different personas, starting from FL researchers. We have like simulation environments that can be really useful to develop new algorithms, data scientists to try to understand large distributed data sets, and platform developers who want to use federated learning in production. There are several integrations with different frameworks. Here we have XGBoost, for example, is very popular for big data analysis, mostly tabular data. And MONAI, we have that integration, which is the focus today. I won't go into detail of all the other things, but there are like things that you need, like a dashboard, in order to run this in real-world production. What's also interesting to understand kind of the demos, which I will be showing later, is this kind of principle, this primary setup for an NVFlare job. We call basically an experiment. You can define a job configuration that tells you what kind of algorithm should be running on in your federated learning framework. And the main idea is pretty much inspired by open MPI, high performance computing type workflows, where you have the server running a controller workflow that is then assigning tasks to different workers. In this case, the client, the FL client, is a worker running a certain executor to execute that task. There are also options to filter the data that comes from the server or before it arrives the worker. And most commonly used are these actually filtering of the results of the worker. Like if you think about data leakage protection, privacy preserving federated learning, you can apply encryption here or add differential privacy filters before the model updates leave the client and are sent back to the server. So it's really this interaction between the controller that basically says, now train, now give me the weights, now start the next round, right? So, and the workers, which are pretty much dummy computation machines, right? Executing the task that has been defined. Within NVFlare, we have a lot of examples, not necessarily in medical imaging, but more general FL applications that show different algorithms. Not all of them are currently implemented in the MONAI FL MONAI algo. So there's something where we can also ask for help from the community. Maybe we need some more work to support all different variations, right? You can think of different loss functions that are useful for FL scenario, like the fed procs, is like adding an additional regularization on the client, things like that. We're planning to basically support all these more common federated learning algorithms in the near future. And yeah, there are some examples for general computer vision, like more toy type examples to understand the algorithms with CIFAR 10, but then we have a lot of examples for medical imaging using MONAI as well, which I think Charashri really made the case for why federated learning is useful in the medical sector, right? Okay, and then these are the filtering options regarding privacy, which I want to skip for now. Maybe just to mention, you can use NVFlare also with homomorphic encryption, which allows you to encrypt model updates before they leave the client. So then they're secure. The server doesn't have a decryption key, so it just does computation on the encrypted values. The nice thing about homomorphic encryption is that you can still compute a sum in the encrypted space, and if you send back the encrypted result to the clients, they can decrypt and get the same result as if you would do the summation in raw space. So in that way, the server is really blind to the model updates that are being sent from the clients. And then differential privacy is something I won't go into detail today, but if you're interested, there's a lot of information here. We have several institutions and companies that are using NVFlare in production already. And quickly, we have a working group that is led by Charashri, Daniel Rubin, and myself, really focusing on federated learning with MONAI. So if you're interested, we're always looking for new contributors and discussions. Please reach out to me, and that's my email down here. Maybe I can put it in the chat later on as well. Okay, so now I actually would like to switch to my workstation where I can run some demos. Let me see if that works.
Yeah. Also, really quickly, Holger, there was 2 questions that came in. I don't know if we want to answer those now before we kind of switch over.
Sure.
Okay, so one was, and I think you maybe skipped the slide for it. What are the different privacy preserving algorithms? I think you did mention you had maybe a slide on that, but do you want to talk about? Yeah.
So one that is working really well is the homomorphic encryption. In that way, you're basically guaranteeing that no raw information is leaving the client, right? The clients have the encryption keys. Server doesn't have any keys. So all the information is being encrypted. the server can then do the aggregation in encrypted space, send back the encrypted result without leaking any information. And that's on top of the communication channels, which are already encrypted, right? So within NVFlare, we use like TLS encryption, which is kind of state-of-the-art encrypted communication. So, but if you assume that a server gets hacked, then with this homomorphic encryption, you can the hacker can still not access the underlying data. And then on the more information theoretic side of things, we can do differential privacy approaches like the sparse vector technique, something we have been working on, and there's a paper that explains that from our group. Maybe the advantage there is that you're also reducing the risk of the model memorizing something about your underlying data. So the homomorphic encryption is really about making the FL algorithm itself secure, right? You don't want to send model updates that leak information. But if you then have your trained model and you deploy that somewhere, there might be still some memorization, right? So I think these two techniques can be combined. But maybe if you have the homomorphic encryption, then you can be less strict on your differential privacy constraints. So they can kind of work together.
Got it. Okay.
Any more questions?
Yeah, there was two more here. So one was also about the numbers related to accuracy, which you kind of have the dice scores there showing the differences between it. Are there any links or anything else that you have as a reference for just general, I guess, accuracy? I was assuming because this is the same person who asked the previous question. I don't know if it's with regard to the privacy, different privacy methods, or just generally accuracy. I was assuming in regard to some of the privacy preserving algorithms, and then if it affects any accuracy for that.
So, I mean, homomorphic encryption, you can also have certain settings that affect how well the data is encrypted, but that causes a little bit of an error, numerical error in your result. So it's not exactly the same result that you would get in the raw space. But like if you look at these examples in the NVFlare repo, we don't see any impact because it's really just, you know, numerical rounding errors kind of thing that don't impact the model performance. With the differential privacy, you can see that like the orange line, right? It takes longer to converge, and probably the final accuracy is a little bit lower than the model trained without differential privacy, or at least compared to the centralized baseline here in blue, right? So those trade-offs currently have to be made. Like if you're concerned about the privacy leakage, you might need to sacrifice a little bit of model performance.
Got it. Okay. And then the last thing they asked was, is there anything related to protecting PHI, which I guess is along the sort of the same line of what you're talking about here, but anything else you wanted to add regarding protecting PHI data?
I mean, there's, of course, additional steps on the client side that you can take. You can make sure that your client worker is running in a sandbox or in a Docker container where it only has access to the data that you want to make available for the training, and that can be anonymized data, right? So I think those kind of additional IT security steps should be taken.
Got it. Okay. I think those are everything for now, so we can probably
maybe
head over.
Maybe one more thing is about the code security as well, right?
Yeah.
There are ways that you can maybe make sure that only code that is authorized to run. I don't know if Chris is probably talking about this later, but we have some authorization protocols as well about who can run what type of task in this federated learning scenario. So all that kind of role assignment and security about the personnel having access to these systems also, of course, plays a role.
Got it. Yeah, that makes sense. Chris, do you have anything to add in here? Do we just want to talk about that later? I don't know if you are covering that later or not.
Yeah, I can go into that in a little bit later.
Okay, let's do that.
Okay, cool. So let me stop sharing here. And I should be able to share something on my Linux workstation.
Yeah.
Okay. So if you go on the project MONAI tutorials, you're probably aware there are all these different topics here. One is also the federated learning. So as we said, the MONAI algorithm itself is a kind of agnostic to the FL framework that you want to use. So I'll also show this. If you go in the documentation, right, this is explaining the client algo API. Is large enough?
Yeah, that's better there.
So you can see there are some like base client classes that don't have much more of a like life cycle management type of calls that can be optionally implemented. And then, as I said earlier, the client algo has basically these very basic functionalities, like it's asking for training the model, evaluating the model, getting the weights. And we also have an integration for statistics workflows, like getting summary statistics from the data. So I will actually show that example as well. So this is the abstract base class. And then if we go back, the MONAI algo is the one that if you use that implementation of that base class, you can basically work with the MONAI bundles from the model zoo without any additional code changes. And then this has, of course, some more arguments like the bundle root. You can set the number of local epochs. Typically, the MONAI bundle is set up for centralized training, right? So we have like a long number of epochs. So we override this here by the local epoch setting, which is the number of epochs per FL round. And then you have an option to send either the full weights back or weight differences with respect to the state of the global model in the beginning of the training. Then we have these configuration files that can be, if the bundle is using YAML, then you would need to change this here instead of the default JSON. Then, we have some option for allowing the client to run multi-GPU. And setting the determinism. You can optionally set a key for deterministic training. And if you're interested in experiment tracking, I don't know if this was talked about yesterday, but
yeah, we actually didn't talk much about the integration for that because that's pretty recent.
Yeah, so this is kind of the latest change to this class actually, is allowing MLflow integration. So you can set your tracking URI here to write training results to MLflow. Okay, so I think maybe if there's any questions at this point, if not, I'll move on to the demo.
I don't see any questions right now, so let's just move on. Actually, one just came in. Two came in. Can we integrate weights and balances or DVC or WMB and or DVC? No.
Yeah, I think so. I mean, it's already here. You can specify which handler, right? So you could have like weights and balances handler here instead of the MLflow handler. So the tracking feature is more general for different integrations.
Yeah, and I'll go ahead and put a link. I think there's a link to that. I'll put it in chat as well for how you can kind of do some of the integration work. And then the other one that came up was, does the central server have to be in cloud or can it be on-prem?
It needs to be reachable by the other clients, right? So it can be on-prem in that sense if you have your firewall open to allow the other clients to communicate.
Yeah. I think this goes back a little bit to probably some of the security stuff that you mentioned earlier as well. Kind of, there's different types of security. where even just getting a connection to the host and how that works, whether it's on cloud or on-prem, how that's exposed. I think there are certain caveats and issues that you have to think about for either of them. Later on today, we'll actually see AWS present. And so that'll be an example of how would you do this in the cloud. But yeah, I think either way that there's some issues you have to think about.
Okay.
Yeah, I think we can probably move on. Yeah.
Well, yeah, we can go into more detail if needed later.
Yeah.
So as I said, so this client API, we hope that it can be supported by different FL frameworks. I think, as you know, this field is kind of growing quite rapidly. So there are a lot of different approaches for running federated learning. We already have like an OpenFL example and a Substrat example. They're currently not using this latest API. We're working on that, but they're using more general MONAI components to run training. But with NVFlare, we have this this integration right now. So you can visit some of the examples. I will talk about these simulation examples now. Setting it up for real world is a bit more advanced. So for the researcher persona, it's probably more useful to start with the simulation. So there's some instructions on how to set up a virtual environment, install the requirements, which I already did. And then you can basically download your bundle. So here we're downloading the Spleen CT segmentation bundle. You can specify the version and then download it to this job name. So this is like a NVFlare specific job that will contain the bundle, as I said, and then that can be distributed to all the clients. So let's see if that works. Here I'm in the same folder, the Spleen segmentation simulation folder. Okay, so this has been already downloaded, so it's not really downloading it again. But yeah, we can also check the folder structure. So you can see there are these two client and server configurations, which are NVFlare specific. And then here's the bundle that contains all the standard files that we have in the bundle, like the train JSON. We are mainly using this train and evaluate JSON for setting up the MONAI algo. Now the data. So again, here we have a little script that uses the functionality to download the data, and then in this configuration file, this command is basically replacing or updating the data directory. Okay, this was also already downloaded, of course, so it doesn't take that long. So here I have my PyCharm open, which points to the same folder. And we can, this is the job that I will show. And maybe here is the training file. So you can see this is, again, standard MONAI bundle. It's defining a unit. Some dice cross entropy loss, optimizer, and it transforms the training.
Yeah. And if people want to know more about bundles as well and go into them, I put a link into the docs page for it. But also yesterday we went over some of this as well. Actually, the Spleen bundle, we actually went over and showed a little bit of. So when we post the videos for that later, hopefully I get early next week, definitely take a look into that as well. So you can kind of get an idea of, kind of break down how to use a bundle and the different pieces of it as well.
Right. And now, for interest of time, again, I'm reducing the training data set size. Let's only take 2 cases. Okay, so back to the instructions. So now we have this is the NVFlare simulator. So you can, to try things out, you can start with one thread and maybe 2 clients. So in that case, if you're on a machine with resource limitations, like say you have only one GPU, you can actually simulate n number of clients, and they will be executed sequentially. So in that way, you can use the same GPU to simulate, a large number of clients. It will take longer, of course. But just to show you this, so you can see total clients went up to 2. And now it's simulating the run on the first client, loading the data set. Okay, we're not going to go through this now. But like on my machine, I have 2 GPUs. So I can actually use 2 threads. So each client is running on its own thread. I can give optionally the name of the clients. That's useful to match up some configurations or the data list for local experiments. And then you can define which client should run on which GPU. So you can even have several clients running on the same GPU, right? And then maybe really make use of your resources. Okay, so now you can see again 2 clients, but you can see that both are running starting at the same time, right? So now they're loading the data sets. We reduce that to 2 cases, and it's 9 cases for validation. It takes a bit longer to load that. But here, I think the bundle is using the cache data set, so it's loading that all into cache, and then you don't have to load from file at each training round. Then you can see here the MONAI algo gives you some information, right? It's getting the weights from the server, so it's converting that to match the local state dictionary. Update basically the local state dictionary of the client, and then start the training. Okay, so then there are some instructions here how we would do multi-GPU training. I mean, here I could only show 1 client because I only have 2 GPUs, with 1 client using 2 GPUs, but I think we don't need to run that. And then for visualization, you can use TensorBoard. That's typically already set up as part of the bundle, right? In MONAI, we have the TensorBoard stats handler, I think it's called. So running that on the output directory that we specified, we should be able to see that right here. So you can see the 2 training curves for the 2 clients. And yeah, this seems reasonable. And then here you can, one maybe interesting thing is that each iteration, you can see the loss. And then every couple of iterations is actually when we're updating the global model. So you can see the evaluation of the global model. So what happens is that when the clients receive the current state of the global model, they run an evaluation on their validation set. So then we know like how well does this global model currently work on all the validation sets of the clients. And that information is actually being sent back, like that validation score is sent back to the client to the server to then it can basically do a model selection. What is the best global model based on the average of all the validation scores? Okay, so this is a phenomenal way of running things. Next, you do this using just quite useful. So let me kill this. So you can use your favorite IDE here. I'm using PyCharm, and I prepared some breakpoints. One is like the scatter and gather workflow. or controller in the NVFlare side. This is actually the standard federated averaging controller. So it's called scatter and gather because it's taking the current global weight and scatters it, so distributing it to all clients. The clients run the training and send back the model updates. So it's gathering those updates to update the global model. So now in PyCharm, you can basically use this NVFlare simulator, and then you have the same parameters again to define here. Kind of for the debugging purpose, it's maybe best to start with only one thread and one client, but you can also run several clients for debugging. So if I run that, yeah, now it's starting off with the controller. So this is the server side. Controller is starting. We continue. Then now we can see on the client side, we initialize this client algo base class, and this is the client algo executor that we have in NVFlare. So that piece of code is basically doing the integration with MONAI FL components. So first we're calling the initialize. We tell it like this is your client name, and this is the current working directory on the client, which is all controlled by the NVFlare system. And then if you continue, you can see now the client is loading the data set. Loading the validation set. Could have also reduced the number of cases there, I guess. Take some time. And yeah, these kind of warnings can be typically ignored. So now this is what I said earlier, that the client is receiving the train task, basically. This is the train logic, but it's first running an evaluation of the current global model. So again, the client algo is asked to validate the current global model. And then it's kind of creating this test report. So like the initialization seems to be taking a bit of time now. I don't know what's going on. Oh, there we go. So the debugging, of course, you can look at the test report, which is it's what we call an exchange object, which is actually a MONAI FL concept that we're using to standardize what is being exchanged between client and server. And here you can look at the metrics. So you have the validation mean dice, validation accuracy, all based on what is set up in your bundle configuration, right? And yeah, and then the next thing would be the train. Maybe run it. See if we have enough time. Yeah, I think we still have some time. So it's doing 10 epochs of local training, but over a small data set in this case. So it shouldn't take too long. And then the next thing would be, again, client algo get weights. So then after the get weights, now we're back on the server side. The server basically received the result and is already in the next round of training, right? So now, because I have this breakpoint here, the client keeps asking for the next task. It's kind of saying, yeah, I finished one task. What's the next? Okay, so I think that's enough for showing the way of debugging these kind of FL components. the final example I wanted to show is the federated statistics. So that's something we found we think is very useful for the medical imaging use cases, right? You want to get some statistics about how your data set looks like, maybe what's the intensity distributions of the client's data set. But of course, we want to have data privacy in mind. So we're not going to send back the result of individual cases, but summary statistics like the full histogram of the client. So in this tutorial, there's also something about section about federated statistics. You can run that from the command line, or you can actually look at a notebook, which we have here. Again, this is downloading the spleen bundle, downloading the data. So this is kind of the end-to-end workflow. And then now in the notebook, you can use this simulator runner class directly to specify your local setup, like number of threads, number of clients, number of GPUs. So if I run that, it's this is the NVFlare output, of course. So hopefully this doesn't take too long. Again, loading data sets. And now we can see that the class that is used for the federated statistics is actually MONAI algo stats, part of the MONAI components that, again, take the bundle configurations as input to define the data sets. And then we use the actual functionality from the MONAI's auto 3D stack feature or module to compute these statistics, because for the automated machine learning, you also want to see how your data set looks like, right? So we're actually using the same functionality here to compute the summary statistics. Okay, so this is already finished. So now there are some examples of how you can visualize the results. So we're using here, the results are saved under the simulate job folder in a JSON format. And you can visualize the entries. So here telling us how many cases each site had. So if you remember, training set was only 2 cases, validation was 9. And then here I just, each client is using the same data. So just for simplicity. And then if you display these histograms, you can see it's computing both the local validate and train data sets and the total data set, and then also the global data set. So of course, by adding these up in counts, it's not directly comparable, right? So then you want to also plot maybe the normalized histogram. So here it is the option %, which then you can see, as I said, it's the same data set, so they kind of line up quite nicely. Okay, yeah, if we go under the simulate job folder, there's also, as I said, it's using the auto 3D stack functionality. So the the server is also collecting these data statistics for each client, which are much more comprehensive. But I currently have no visualization tools for those. But again, this is the histogram information, but then you can also get more detailed stats about panels, median, swap sizes, and things like that. But so this is, I guess, the original data shape. So all of that could be very useful to know to inform your design of the actual training algorithm and network design that you want to use. And as you can imagine, we can integrate that with Auto 3D Sec, hopefully in the future as well. I think that's the major things I wanted to show. Are there any more questions?
Yeah, a few came in. So one, Chris did say he was going to talk a little bit more about it, but I'll at least mention it here. Someone asked if they use custom classes in a bundle, or just generally, I think the question is more is if you have custom code, how does that get pushed to clients? How does that, do they have to be in sync with it? How do they install any library dependencies that custom code may need? How are those sort of things sort of handled? Again, Chris is probably going to talk more about it a little bit more in depth, but if you, Holger, wanted to mention anything about it at all.
Yeah, so I mean, there are different security settings that you can set up in NVFlare. Of course, each FL framework might handle this slightly different, but you can basically either allow code being shipped as part of the bundle that is being distributed through the server, or you cannot allow it if you're in a more security strict setting. In that case, maybe you need to have a separate approval process and install the code on the clients, so it's available to be kind of run as through the configurations.
Yeah.
In the bundle, like let's say you are allowed to distribute Python files through the bundle, then they would be just part of this. Like here, I have this job folder, right, and the app actually contains this bundle, this Spleen segmentation. And I think in Spleen that we don't have any custom code, but there could be like a script folder here, which contains custom code and that you can reference in your bundle configuration. Right. I think in general, you can just add whatever kind of target path you want here. As long as it's in your Python path, the client should be able to access it.
Yeah, that makes sense. And I think this goes back even to what Jayshree was saying of coming to an agreement with who you're working with and the different people in the group and the cohort of, can you share it? Is that safe enough to do it in the cohort? But there are, again, like also like Holger just said, is it also is dependent on the library itself. So NVFlare has its way of doing it. Under the MONAI repo, we have some other examples. Each library might do it a little bit differently. So it's something to look into as you're kind of thinking of starting an experiment. Next question. Server and clients should have Linux. Does it support Windows? So what is the general OS support for any of these?
I think we have several people running NVFlare on Windows as well.
Yeah.
So it's possible. It's not something that we're testing a lot, but again, Chris might be able to say more about that because it really depends on customer platforms.
Yeah, most of the I can chime in quickly. Most of the scripts and configurations are designed with Linux in mind for paths for scripts to start clients and servers. Typically, when we see users on a Windows system, they're typically using WSL and running in like an Ubuntu VM for the Flare clients or server.
Yeah. Okay, cool. Next question. Are there any internal quality checks present for the data and labels of the clients?
I think this kind of federated statistic workflow is probably the best way of ensuring the data quality as kind of as a pre-processing step. So as a data scientist working on this distributed data set, you can run these kind of analytics workflows first to get an understanding of the data, to find out, like find outliers. There could be, of course, pre-processing errors that happen on the clients. You can actually run pre-processing workflows as well in NVFlare, as long as it's allowed, right?
Yeah.
But you could set up some kind of DICOM to nifty conversion code to execute on the client. It's all very flexible. It's really a distributed compute framework. The other way of to look at the loss functions while the training is happening, if you have outlier clients, they typically that don't converge and things like that, that typically indicates that something is wrong with the data.
Got it. Okay. I think this also goes back even to what Jay Shri was presenting at the beginning as well of some of the things you just have to sort of think of the data of, even if it comes from a different scanner or a different machine, what are the ranges in those? And I don't know that you can necessarily do anything at runtime to check some of those things. I mean, maybe there are, but it's sort of thinking about what does your data look like? And again, maybe doing some of that exploration beforehand to make sure it's the right classes that you're actually labeling, and that the institutes use the same categorization for everything as well. And what does the actual distribution of things look like? So I think that's another thing to kind of consider, is that it's probably applicable all throughout the process that you're looking at an experiment as well.
Right. And yeah, dealing with heterogeneous clients is like a major research question in federated learning. So we do have some of the algorithms that try to address this problem, but of course there's always challenges, right? If you cannot centralize the data set, so you cannot really sample in the same way as from the data distributions as you would do in a centralized setting. You have to do some kind of algorithmic tweaks to better handle those domain shifts. But at the same time, from our experience, I think these differences are actually what helps you training more generalizable and more robust models that hopefully work across a wider set of patient populations.
Yeah, that makes sense. All right, next question. And this is sort of just broader. I think this isn't really related necessarily to federated learning. So anyone can kind of chime in here, but they're asking, are there any tools to interactively visualize the 3D segmentations? And if it's GPU accelerated, the better. They mentioned that they already use ImageJ. Some people in chat mentioned Slicer, ITK Snap, ParaView. There's also OHIF. There's also some, I think in TensorBoard, there's a plugin as well for ITK where you can visualize some of the things in it in 3D and like have some nice 3D rendering within TensorBoard. So it really depends on where you're looking to do those visualizations. If it's part of, I guess, the workflow in like a notebook, there's ways to do that as well. I know we've been experimenting with integrating 3D Slicer into a notebook, so you can actually have it spin up and run. You sort of execute a cell, and then it'll actually load the data from Slicer and have a little mini Slicer client in the Jupyter notebook running on a VNC client sort of behind in another Docker container, but it'll display in the notebook itself. So that can kind of integrate into your workflow. So I think there are a lot of different ways to do that and go about that. But I'll let anyone else chime in here if they have any suggestions or ones that they use.
So the question is about in general visualization or in the FL setting?
I think just generally, but if there's also anything specific to FL that you want to mention.
I mean, I just wanted to mention that we also have examples where you can stream TensorBoard events to the server.
Okay.
Of course, there are some privacy concerns related to that. So maybe sending the segmentation mask to the server is fine in certain settings, but you don't want to stream the original data, right? So again, this kind of needs to be carefully handled, and the code might need to be approved by the clients for doing this. But I know some FL platforms actually are sometimes giving the option for the researcher to see little thumbnails of the original data. You kind of see, like, I see, oh, this X-ray is actually inverted to what I'm actually expecting for my model, right? So those kind of issues with the data could be even seen on like very downsampled versions of the original data or some noisy versions of the original data. So it's possible. Sometimes they even give like a temporary access to the data, right? Just to see what's going on and help with setting up the data sets. So those are all interesting questions, because now you're a researcher working with a FL system, right? It doesn't have direct access to the data anymore.
Yeah. Cool. The one last question here is, so yesterday during the MONAI label piece, we talked about active learning. And so they're asking whether if there's active learning in the context of federated learning, can you apply to there? How does that work? Are there options, I guess, in Flare or in MONAI that help with that?
I think it would be a really nice integration piece if you can do that. We haven't done it yet, but you could definitely see several MONAI labels running on different clients, right? And they use active learning to train a global model together. And then, yeah, I think that would be a really nice use case.
Yeah. Have you generally heard of any research involving active learning in NFL? Just kind of not even MONAI related, but just generally at all?
I think people have been thinking about it, definitely. I mean, this is technologies that can work very nicely together, I think.
Yeah, that makes sense. Let's see, another one came in. If during federated training, we understand that a particular client has wrong data and labels, is it possible to exclude that specific client in the next training rounds?
Yes. Yeah. Of course, there's the question if you can automatically detect that somehow. But if you manually notice that there's an issue with a client, you can exclude those. As I said, as I showed you, this controller workflow is actually gathering the updates from each client. So you could put in a filter there and say, like, this one I just throw away, or I give it a lower weight, right? Or there's actually also a way to define what we call a deploy map. So you can, even though you have many clients connected, you might just run an experiment on a subset of the clients. So that's also possible.
I guess on top of this one, they didn't necessarily ask this, but if someone, say a client drops during the training or they're taking a long time for it, how does that kind of play into the workflow as well?
Yeah, that also needs to be considered. Typically what we have is this concept of a minimum number of clients that we're waiting for responses. For like in settings where you do have unstable connections to the clients, you might want to set it to a smaller number than your actual number of clients. So not all clients might be contributing to the model update at every round. But yeah, those are again active research. Like there's this straggler concept and ideas of using asynchronous updates of the global model. So the model client updates might be coming in at different times. What I showed today was mainly the standard federated averaging workflow, which is a synchronized.
Yeah, so that it kind of waits for a certain number of rounds and then it averages, and then it kind of has to wait for that instead of, like you said, asynchronously, always kind of just merging as possible.
Right, exactly.
Got it. Okay. That was the last question here. I don't know, Holger, did you have anything else to present at all and want to finish it off, or was the demo kind of the end of your presentation?
Yeah, that's the end, actually. I don't have anything more. Yeah,
cool.
only to say, please reach out. I will put my email in the chat. If you're interested in the working group and so on, we're always looking for contributions.